Hello students, good evening. Welcome to GATE Wallah. Welcome to lecture series on theory of computation. Today is our lecture number 7. Topic is on regular expressions. So yesterday also we studied regular expressions. Our today's session is continuation of yesterday's session. So in today's session we'll discuss more in depth on regular expressions topic. Yesterday just roughly we have seen what is regular expression. Actually in today's session we will study clearly what is a regular expression, how it will be useful, how we will get the questions in GATE examination from regular expressions. This is what our today's agenda. Right. So as I told you yesterday, after DFA topic, that is after finite automata concept, next most important concept in regular part is regular expressions. The name of the first topic in theory of computation is finite automata regular expression. Anyhow, finite automata is very important, especially deterministic finite automata topic. That is very important one. So we studied what are the major concepts in deterministic finite automata, important topics from where we'll get questions. Those things already we studied. After DFA, so in DFA actually we studied this DFA construction, DFA minimization, DFA to language detection. These are the major three things. DFA detection is anything required for all these concepts. So after that, next important thing in regular part, for any language DFA exists, that is called as regular. The meaning of regular itself, DFA possible things. So today, instead of regular languages, we are studying regular language in terms of expression. So that is what our today's concept. Right. So what is the importance of this regular expression? Why we want regular expression? Assume I want to write a complete language. Complete language. That is represented with sigma star. Sigma star. Sigma star is a regular expression representation. Let me explain. So whenever you say complete language, for complete language we have a DFA. The DFA for complete language is this is a minimal DFA I am constructing. We have seen the how we will do minimization in yesterday's class. Whenever there is a DFA, definitely language exists. The language for this DFA will be, let me write the language here. What it is accepting? It is accepting all possible strings, accepting epsilon, accepting A, accepting B, every string. So I have to write all possible strings. Instead of writing, so this is the language. This is the language for this automata, for this DFA. That is regular language. So for any DFA, whatever the language is possible, that language is called as regular language. Now the question is, why you have to write this much bigger way? Why we want this much bigger one? Writing this in terms of this much. It is taking space complexity. Here we are getting the problem of space complexity. So instead of wasting this much of space here, just simply I can write this as A plus B whole star. This is our regular expression. Mostly in GATE papers, he will give DFA. What is the language? Instead of mentioning all the languages, they will simply language, they will represent in the form of expression, that is regular expression, because it is simple to represent. That's why the definition of regular expression is the simplest way of representing regular language, known as regular expression. That's all. It is simplest way of representing. So regular expression main advantage is we can represent languages in a very easier way. That is called as regular expression. If you represent languages in a easier way with very less space, that is called as regular expression. In order to represent this is a mathematical concept. We'll use some operators, operands and all this. So this is called as expression. So regular expression. So anyhow, the advantage of regular expression is easiest way of representing, simplest way of representing. It takes less space. That is what the meaning, right? We have some important points here. Whenever you say language is regular, whenever a language is regular, definitely regular expression possible. Sometimes students generally will say like this: if I ask construct regular expression for this regular language, construct regular expression for this DFA, they will say they are feeling difficulty to construct. Whenever they are feeling difficulty, they will say, sir, not possible. Completely wrong answer. If DFA possible, definitely regular expression should possible. DFA possible means language is regular. If it is regular, regular expression possible. So whenever DFA exists, we cannot say regular expression is not possible. We can construct. There are so many multiple ways are there to construct. That's why for every regular language, regular expression exists, right? Now the question is, for every regular language, if regular expression exists, I will give one regular language. I will give one regular language as this is my regular language. Good evening. So today our concept is continuation on regular expressions. Welcome students. Let us enjoy regular expressions topic. Very beautiful topic. Compulsory question in every gate paper. Right. So this is a regular language. This is the regular language. Okay. If we say this is the regular language, there should be a regular expression for this. If this is a regular language, there should be a regular expression for this. What is that regular expression? How it looks like? That is our question. So the regular expression, definitely regular expression exists. How many regular expressions exist? For one regular language, how many? If it is only one possible or many possible? For this, the important point is, for one regular language, many number of regular expressions. For one regular language, many number of regular expressions possible. So many. So language, if language is one, for that so many number of regular expressions possible. So here is the generally students confusion starts. If these many regular expressions are there, which one we have to construct? Any one is okay. So there is no minimization concept here. So any regular expression according to generally will construct according to the options. If it is a MCQ question, as per the options we'll construct. But the thing is, for one language, many number of regular expressions possible. Let us see for this how many we can construct. A star B star is the one regular expression. So any number of A's, any number of B's. One more regular expression I can construct like this. A plus whole star, B plus whole star. These two are equal. One more regular expression I can construct. So these are the different type of regular expression for the given one regular language. That's our statement is, for one regular language we can construct so many number of regular expressions. Okay, what is in a reverse way if I ask? For one regular expression, how many number of regular languages can be generated? Regular expression, how many number of regular languages? From, if I give like this, a plus b whole star, a plus b whole star, how many number of regular languages can be generated? For this, the answer is only one. This is important thing. So for one language, many expressions. For one expression, only one language. So whenever expression is given, only one language is possible. Right. That's why in the construction time, we have to keep all these things in mind. Whenever we are generating regular expression, in today's class, we'll see generation of regular expressions, how we can construct regular expressions. So in order to construct regular expressions, how our concept will be going on. So first one is, regular expression is nothing but simplest way of representing a regular language. The easiest way of, the smallest way of representing a regular language. Regular language representation in a easiest way. That is called as regular expression. Right. Next one is, for every regular language, regular expression can be constructed. If a language is regular language, regular expression can be constructed. Here to construct regular expressions, we'll use three operators. Plus operator, these are important. To construct regular expressions, three operators will take the help of three operators. Plus operator, known as union operator. Dot, this is a dot here, known as concatenation operator. Concatenation operator. Star is known as clean closure operator. So with the help of these three operators, generally we'll construct regular expressions. Let me write how regular expressions looks like. R1 plus R2. This is one regular expression. R1 concatenation R2. Other regular expression, R star. So this is we constructed with the help of union, concatenation, clean closure. Union operator, concatenation operator, clean closure operator. These two operators generally used in order to construct regular expressions. Union. Generally, if you see in a normal expression point of view, whenever you use union, we can take the English language words for this, or I can use or. Union meaning comes as or. Concatenation meaning comes as and. Clean closure is repetition. Repetition. This is what the general meanings of union, concatenation and clean closure. Right. So this is what the brief introduction regarding regular expression. Regular expression is nothing but expression representation of a regular language, simplest way of representing a regular language. To construct regular expressions, we need the help of these three things, these three operators. Names, union operator, don't say plus operator, dot operator. There are names here. Union operator, concatenation operator, clean closure operator. Clean closure is generally for repetition. Concatenation generally used for AND, to say AND. Union is generally used for OR case. So these are the different possibilities of these operators. For one language, many expressions possible. For one expression, only one language. So these are all the some of the basic point related to regular expressions. Now what we will do, let us try to construct regular expressions for some of the regular languages. The first thing here is, what is the regular expression for this language? A power n, b power n greater than or equal to 1. What is regular expression for this language? It is very easy one. Regular expression, the name itself saying regular. Whenever you use the term regular, that is suitable only for regular things. That is suitable for DFA possible thing. For any language, DFA not possible, regular expression also not possible. For any language, DFA possible, then only regular expression possible. DFA not possible, regular expression not possible. DFA possible, regular expression possible. So what about this language? DFA possible or not? This we have seen clearly. This is a violation of our deterministic finite automata. So for this, DFA not possible. So regular expression not possible. DFA not possible, so regular expression not possible. Good evening students, welcome to regular expressions topic. Let us enjoy regular expression in today's session. Many students are joining slowly. Right. So today is our yesterday's continuation on regular expressions. That's why if you want to check whether regular expression possible or not, there is no new concept here, same our DFA concept. First check DFA possible or not. We have seen when DFA not possible, one thing, comparison exists, that is dependency exists, DFA not possible. Formed over only one symbol, common difference exists or not. Common difference exists, DFA possible. Common difference not exist, DFA not possible. Wherever DFA not possible, for whatever the language DFA not possible, regular expression also not possible. That's why now I'll give some languages. Let us see where regular expression is possible, where regular expression is not possible. If not possible, even if you try for 100 years also we will not get. That's why first conclude, this is the reason for this not possible, leave it. Wherever possible, for those we will try to construct regular expressions. Right. Let me give some languages here. So L1, what is the regular expression for this? First let me write some languages. These are the three languages. Let us try to see what are the regular expressions for this. Can anyone tell me what is the regular expression for L1? What is the regular expression for language L1? Same concept, DFA concept. Whenever DFA possible, regular expression possible, DFA not possible, regular expression not possible. So what is this one here? There is a comparison, number of A's greater than number of B's. So dependency is there between these two symbols. Whenever comparison exists or dependency exists, DFA not possible, that is not regular language. So regular expression not possible. Regular expression not possible for L1. For the language L1, we cannot write any regular expression. There is no regular expression for this. What about for L2? A power n, B power m, n is not equal to m. That means sometimes number of A's can be more, sometimes number of B's can be more. First of all, can we construct DFA for this? For the language L2. Similar thing we studied in DFA class as well. So for L2, DFA not possible, DFA not possible, so regular expression also not possible. Not possible, not possible. So there is no regular expression for L1, there is no regular expression for L2. What about L3? 2n, 2m. 2 times of n, 2 times of m. Regular expression possible for this? Yes, DFA possible. There is no comparison in these two. We don't have any comparison. Here number of A's can be anything, number of B's can be anything. There is no dependency. If I take 2 A's here, is there any restriction on number of B's? I can take 100 B's, I can take 1 lakh B's also. But whenever we are generating A's, it is multiple of 2 times. That is not dependency. That is its independent condition. Condition on A. That's why there is no dependency. Clearly regular expression is possible. The regular expression for this will be A's, 2A's repetition, 2A's repetition, 2B's repetition. So repetition of A's, repetition of B's. 2A's repetition, 2B's repetition. So this is the regular expression. So these are some of the regular expressions for this language. Sometimes possible, sometimes not possible. That's why whenever you are generating regular expression, always keep in mind when it is possible to generate, when it is not possible to generate. So this identification is important. If it is not possible, that topic will help us to conclude about DFA, to conclude about regular expression, to conclude about regular language. So whenever you say not possible, we can conclude 3 things. DFA not possibility, regular expression not possibility, it is not comes under regular part. It is not a regular language. That's why. So possible or not possibility is a common concept in all these topics. Right. Let us try to generate regular expression for some of palindrome. So palindrome is one of the famous concept, famous problem in our theory of computation. So palindromes we'll study in regular finite automata time. Palindromes we'll study in push down automata time, context free. Palindromes we'll study in Turing machine time as well. So palindrome is a common thing. What is palindrome? Reading from both sides gives the same word. So this is one of the palindrome. Ma'am, palindrome. Read from this side. Read from this side. Same. Madam, palindrome. Read from this side. Read the same. This is palindrome. Right. Now we want what is the length of these palindromes. I'm writing general palindromes. These are general palindromes. So this is a odd length palindrome. This is a odd length palindrome. But what is the question here is regular expression, even length palindromes. Palindromes of length even. We need to generate even length palindromes over A. Even length palindromes over symbol A. Right. So first let us write what are the palindromes over A. So epsilon is one palindrome, 0 length, this is valid. Then 2s, 4s, all these are the palindromes over A. Read 2s, read from both sides same, 4s same, 6 number of s same, 8 number of s same. So now we want regular expression for this. For palindrome over symbol A of even length. Right. That is simply 2s repetition. 2s repetition, how it will generate? Repetition 0 times epsilon, 1 time 2s, 2 times of this. Whenever you apply clean closure on anything, that gives the repetition of this internal bracket things. So 2 times 4, 3 times 6s, 4 times 8s, and so on. This is the palindrome. Now we'll get the similar question. Construct regular expression that generates set of all even length palindromes. Even length palindrome strings over AB. Palindromes over AB. What are the palindromes over AB? There are two symbols. Epsilon, 2s, 2b's. A2s also even length. Palindrome, read from both sides. 2b is also palindrome, read from both sides. AB, BA. BA, AB. All these are palindromes. Now we want regular expression for this. We need to construct regular expression for this. So here, whenever we are constructing palindrome things, this is the important note. Palindrome languages over more than one symbol are not regular. I'll explain why. Palindrome languages over more than one symbol are not regular. Hence, regular expression not possible. Comparisons are there in palindrome. So whenever question is on palindrome, regular expressions or anything on palindrome. So if the palindrome is formed over just one symbol, we can construct DFA, we can construct regular expression, that is regular. If it is more than one symbol, DFA not possible, regular expression not possible, it is not regular. So reason is, see the structure of the palindrome strings. See this. So the palindrome language representation will be W power R. W belongs to A plus B whole star. Whenever you take any string, we need to generate reverse of that, then only palindrome comes. See the string W, there is reverse of this. See the string W, there is reverse of this. If a string is there, it's reverse, then only palindrome forms. So if you take AB, so a string, it's reverse. So AB from this side. So whenever a string and its reverse exist, comparison exists. Comparison exists, automatically dependency comes, they are not regular. So because of this comparison, palindrome strings comes under non-regular part. But this will not happen over one symbol. Whenever the string is formed over one symbol, there is nothing to compare, there is just only one symbol. So comparison concept is not there. So palindromes over one symbol are clearly regular. We can construct a regular expression because we already constructed. What is a palindrome, even length palindrome over A? 2A star. For palindromes over one symbol we can construct, but whenever palindromes over more than one symbol, we cannot construct. So the answer for this is regular expression not possible. No regular expression. Otherwise, RE, regular expression. Regular expression not possible for this. Reason clearly exists because it is difficult. So whatever, even length, odd length, whatever it may be, whether it is a even length question or odd length question, even length palindrome strings, odd length set of all odd length palindrome strings. What happens to odd length? Odd length palindrome also same thing, just to changes the structure, way of representation. W X W power R. W belongs to A plus B whole star. X belongs to A plus B. This is the structure of the odd length palindrome. Even though it is a odd length or even length, what is there? Clearly there is a comparison. Comparison exists here. Comparison exists. Whenever comparison exists, language not comes under regular. So palindromes over any symbol, one, two symbol, more than one, any symbol, 2 symbol, 3 symbol, 100 symbol, 1 lakh, whatever it may be, they are not regular. So RE not possible. Here also RE not possible. Regular expression not possible. So this is a palindrome questions asked many number of times in GATE paper, more than 10 times. Very, very important language these are. There is a great book on the subject theory of computation, Ullmann. So most of the topics, in majority of the topics, we can find palindrome problems in that book. So for palindrome problems, pushdown automata is constructed, grammar is constructed, but DFS we are unable to construct for more than one symbol. What about this for the English language? Set of all odd length palindrome strings. Odd length palindrome strings means if we write the set format of all these things, English language, all symbols. And so on. This is my language. This is also infinite language. We can generate any number of things here. All these are formal language, so meaning is not important. Infinite language. What is the regular expression for this? What is the regular expression if you want to construct for this language? Here also, whenever more than one symbol, clearly regular expression not possible. Regular expression not possible. Right. So this is about the construction part. So how to construct regular expressions for a given languages, when it is possible, when it is not possible. And similarly, we'll see if finite automata is given, how to construct the regular expressions. Regular expression is given, how to construct the finite automata. So in today's session, we'll see the way of construction of a regular expression from the given finite automata. Before that, we'll see the properties. We'll study properties once, then we'll go for that. So these are some of the important properties. Some type of regular expressions where they are equal, where they are not equal. Hi Sujay, welcome. Welcome to session on theory of computation. Why this property is important is the meaning of regular expression. For one regular expression, for one language, different regular expressions are possible. So where they are equal, what kind of things equal, what kind of things not equal, if you understand those, then it is easy to solve the previous gate questions. Just we'll analyze this because most of the students are new to regular expressions. So how regular expression, when they are in what cases they are equal, what cases not equal. If you are able to understand those, it is easy for you to solve questions, gate questions. Simply remember one thing, whenever we are solving any regular expressions questions, or whenever we are understanding regular expression, is phi is a regular expression representing our empty language. For empty language, there is a regular expression phi. Phi generally used to represent empty language. Epsilon is known thing. I am assuming R is a regular expression here. Whenever you are analyzing these expressions, like on our general mathematics, phi you treat it as 0, assume phi as 0, assume like that, then it will be easy for you. Epsilon assume as 1. So then it will be easy for you to understand these things. Then see the meaning of the first one. R is a regular expression. So R plus 0, 0 plus R is R. If you analyze like this, it will be easy. Concatenation is like our multiplication. R multiplied with 0, 0 multiplied with R is 0. I am just simply telling the way of remembering. If you remember in this way, it will be easy for you. R plus 1, 1 plus R is not equal to R. R multiplied with 1, 1 multiplied with R is R. R star, repetition of R infinite number of times. See, the fifth one is very, very important. Repetition of R infinite number of times. Again, if you repeat R infinite number of times, positive closure. Plus is called as a positive closure. So, repetition, the difference between clean closure and positive closure is epsilon R clean closure, R positive closure. R plus R clean closure. Here epsilon is included, here epsilon is not included. If any repetition includes epsilon, comes under clean closure, does not include epsilon. All repetition except epsilon is positive closure. That is the only difference. So, even if you repeat positive closure times, infinite number of R's only. So, this is also equal to R. R star, R plus. So, R star R is also alpha. Epsilon, infinite times epsilon. Epsilon positive closure also epsilon. Phi clean closure is epsilon. This is the 9th one and 10th one is very important. Phi clean closure is epsilon, whereas phi positive closure is phi. We can prove this as well through DFA, finite automata. So 9th one and 10th one, just remember these three, these two things. This is 10th one. And I'll explain 14th one directly. We'll come to the remaining afterwards. A plus B whole star. Here the confusing part is there are, for same language, so many regular expressions exist. So what type of things equal? So some of the important things we are observing here. A plus B whole star is equal to A plus B star whole star. A star plus B star whole star. A star plus B star. Right. Here we can, let me write this, small change to this. A star plus B whole star. Right. Then A star B star whole star. A star plus B star whole star. All these are equal. Okay. So A plus B whole star equal to A plus B star whole star. A star plus B whole star. A star plus B star whole star. A star B star whole star. All these are the equal things. So let us see how these things will generally help us. In what way these things will help us. This is the question asked one time in GATE paper. To check the equality of regular expressions, which of the following regular expressions are equal? So we need to write expansion of this. Expressions are given directly. What is this? This is generating all zeros. What is this one is generating? Even zeros. What is this one is generating? odd zeros, all zeros, even zeros, odd zeros. What about the first one? Whenever it is union, we can take one time this one time this one. If you take this, we can generate even zeros. If you take this, we can generate odd zeros. What is the meaning of this one? Here also all zeros. So which two are equal here? 1 and 3. So these type of questions. In the previous time, we have seen the construction of regular expressions. We'll get questions from regular expressions in two ways. One thing is way of construction of regular expression. See, construction of regular expression takes a lot of time. It will not complete in a small amount of time. Just we are observing basics in what cases we can construct. For small examples we are observing, but that is actually very lengthy topic. We have different methods to construct those. We'll see in coming classes. Anyhow, this is the basic way of solving questions. Next one is they will give regular expression itself. Whenever regular expression is given, we need to identify language strings, nature of strings generated by regular expression. Based on that, we have to select options. So here this is one type of question. He has given regular expression. We need not to construct. Regular expressions already there. Analyze language from that, then answer question. Sometimes they may give equal, sometimes they may ask which are not equal. There are different varieties. This is one kind of that question. Which of the following regular expressions are not equal? This is also a gate question only. Which of the following regular expressions are not equal? He has given regular expressions. To verify where it is equal, where it is not equal, you have to generate the language format of this, strings format, set format of this. Once you generate set format of this, then we can able to compare them. That is easy to compare them. Right. So what about first one here? We want not equal things. Which are not equal? Clean closure operation. Here clean closure operation is given. Clean closure operation is given. Union operation is given. Sometimes concatenation operation is given. 3 operators are there. So try to analyze. So which operator is producing what kind of strings? Based on that, we need to conclude when we are getting same things, when we are getting not equal things. Let us analyze from the first one. First one is R star. What generally R star generates? R star is the repetition of any number of R's. So if let me explain this separately. The meaning of R star is it will generate epsilon, R 1 time, R 2 time, R 3 time, R 4 time, any number of times. This is R star meaning. If whenever he give like R star, even number of R's, R 2 times, R 4 times, R 6 times, R 8 times, and so on. But whenever R star is given, see the question here, whenever R star is given, all number of R's generated, number of R's in infinite number of times, number of R 1 time, 2 time, infinite number of times, and it's again infinite repetition. Infinite R's, infinite repetition, that is R star. So R star whole star is equal to R star. R plus infinite number of R's except epsilon. It's the repetition that always includes epsilon. So this is also equal to R star. So option A, they are equal. In the option A, we are getting as both are equal. Both are equal. Come to option B. So R star. What is R star here? R star is anyhow infinite number of R's. This is this one. Now the question is, infinite number of R's can we generate from this? What is this one union? We can take either R or epsilon. One time we can take R, one time we can take this. Whenever you take R whole repetition, this is equal to R star again. It's equal to R star. Whenever it is equal to R star, then once all number of epsilon star is no use. Anyhow, epsilon we can generate from here. So this is equal to R star. This is also R star. They are equal. So with this option also both are equal. Right. What about this? This is known thing. No confusion. This is clearly R star. What about this? Here we have two things. R star, epsilon star. It's repetition union. We can take union set of this. What is the repetition of this one? We can generate epsilon. Already it is there here. Double R repetition. 2 R's, 4, 6, even number of R's. Number of R's generate evenly. So R 2 times, R 4 times, 6 times, 8 times, and so on. So epsilon star is epsilon union of this. What is this one? This is equal to R star only. Now this is R star. This is R star. Are they equal? Question is, are they equal? Because R star is generating any number of R's. See what is R star is generating. Now observe from here. So one is R star here, one is R star. Observe from here. Are they equal? Here 1 R is there. Here not there. Here 3 R's are there. Here not there. Here 5 R's are there. Here not there. So they are anyhow not equal. Not equal. So our required answer for this question is so some people, if none of this, whenever none of this exists, they'll attempt to give none of this. But the answer for this, which pair of regular expressions are not equal? Clearly the required option is C option. They are not equal here. Understood? Like this. Whenever regular expressions are given, try to generate the language format of that. Why? So if you, before going to GATE exam, you need to by heart some of these kind of things. Anyhow, by practicing, you can able to remember. If you remember some of this, directly you can give answers without generating the strings. So this comes under here, no? R star whole star is R star. So this kind of thing. So these properties generally help us to solve the questions in a quicker way. For these properties also, if you want to prove these properties, the only way is you can write the set format of this strings, generate strings from this, then it is easy to write. But whenever you are generating properties, see here, a plus b whole star not equal to a star b star. So these properties will help us to solve the questions like that, previous questions. Whenever you want to solve those questions, those are gate questions. If you just if you are having knowledge about this, if you are able to analyze this, then we can able to solve. So a plus b whole star is not equal to a star b star, but where a plus b whole star equal? A plus b whole star equal to a star b star whole star. Total star whenever you give, then only we can generate all possible strings. So in order to confuse you, sometimes they will give in this way. So 11th one is important. And 12th one, a plus b whole star not equal to a star b star, a star plus b star. Because the AB generate string AB combination we can generate from this. String AB we can generate, but AB not possible. From here, only A's repetition or only B's repetition. When they becomes equal, if we have again whole star like this, A star plus B star whole star if given, then they becomes equal. Otherwise not equal. Right. See this one, A star plus A star, any number of A's, infinite A's, union infinite A's, that is A star. So all these are some of the basics. And the only thing, 10th one is very important. 5 plus is 5, whereas 5 star is epsilon. Right. These are some of the important things here. So this is about our today's session. We studied on regular expressions mainly. What is regular expression? Just let us see the overview of today's concepts. We have seen what is regular expression, simplest way of representing a regular language, regular expression. Whenever you say regular language, whenever you say DFA possible, regular expression also possible. Whenever you say DFA not possible, regular expression also not possible. To construct every regular expression, whenever you say regular, whatever it may be, how much it can be difficult, how much it can be lengthier, not an issue. We can able to construct regular expression for that. Whatever may be bigger DFA it is having, don't worry, don't bother about. We can construct a regular expression by using just these three symbols. Symbols means operators. They are called as operators. Union, concatenation, clean closure. Just by using these three operators, we can construct regular expressions. Plus is known as union operator, dot is known as concatenation operator, star is known as clean closure operator. Right. So one more thing is, whenever it is a palindrome, for one symbol palindrome, regular expression possible. For more than one symbol palindrome, regular expressions are not possible because comparison things are there. So we cannot construct any regular expression for that. So there are so many other topics on regular expressions. We'll see in the coming classes. That's all about regular expression. First part, construction of regular expressions, way of solving questions, gate questions from regular expressions. There are two type of questions again. Language is given, construction of regular expression. Regular expression is given, identification of language from that, equality checking, not equality checking. These are some of the important concepts from these regular expressions. Okay students, that's all about today's session. Thank you. Let us continue in the next session tomorrow onwards at the same time. See you all in the next class. Bye bye.